So, as a continuation of the discussion that we already had, today we are going to discuss about the applications of Nernst equation. If you can remember, in the last class we had discussed about the concentration cells. So today we will see how the Nernst equation can be applied in the various electrochemical cases. So for an example, we will consider the Daniell cell in which the concentration of the solution will take Daniell cell, but the concentration of the solution will be this much, 1 molar solution. So as we know, the Daniell cell will look like this, Zn, very well known. So to build the initial concept, we are discussing on that only. This is aqueous, salt bridge, then it should be Cu2 plus aqueous, then Cu solid. Now, if we need to find out the EMF of the cell, the EMF of the cell or E cell should be ER minus EL. Remember, if see the standard state is not being mentioned, so we are not calculating E0, we are calculating E actually. And in the electrode, these are the two reactions which are happening simultaneously. Zn gives rise to Zn2 plus 2 electron, copper 2 plus 2 electron gives rise to copper. Now, as a resulting equation, we all know that the resulting equation will be zinc plus Cu2 plus giving rise to Zn2 plus copper. This much we have discussed earlier also. There is nothing new in it. But from here on, we have to calculate E cell. Let us see how we can calculate this E cell using the Nernst equation. So, electrode potential for the electrodes separately if we calculate. So, first let us calculate for the copper electrode. It should be for copper electrode, it should be E of Cu2 plus oblique Cu is equal to E0 divided by Cu2 plus copper minus, now here it is 2.303 RT by NF copper. Now here it is, log of, we know that in this equation it is copper divided by copper 2 plus. Similarly, for zinc, we should be able to write that E of Zn2 plus by zinc should be E0 of Zn2 plus by Zn minus 2.303 RT by NF log of. But in case of Zn, it is Zn2 plus should be here, right? Zn2 plus by Zn. Now, see carefully these two values. Here ER minus EL. What do you think? ER means cathode. So cathode means copper. So we are basically talking about Cu2 plus copper minus we are talking about E of Zn2 plus Zn. So these two we have got already. If it is equation number 1 and if it is equation number 2. So if we need to find out E cell, obviously if this is equation number A, we will put the value of equation number 1 and 2 in equation number A. So E cell will look like this. E0 of Cu2 plus copper minus 2.303 by RT by NF log of. Now this part, this N actually in both the case is 2, right? And we also know that it will be ultimately coming down as 0.059. So we'll do that, but let us for the time being write down 2f log of copper by copper 2 plus. This part should be we will take the minus sign, and this value of E of Zn2 plus by Zn, which is this much, equation number 2, we will put down this one, E0 of Zn2 plus by Zn minus 2.303 RT by 2f. Here it is log of Zn 2 plus by Zn, and this should be also in second bracket. Now if we simplify, if we very quickly simplify, it is this minus that, so we should be able to write E0 of Cu2 plus Cu minus this much E0 of Zn2 plus by Zn. This we can keep. Then we know that this is minus and this is minus into minus plus. But if we take minus of 2.303 RT by 2f rather as common, and if we take the log, and then if we write down this part Cu Zn2 plus by Cu2 plus by Zn, this part because as you know, if log is an addition, log A into B, we can write down as if log A plus log B. So it was in the form of log A plus log B. We have written down in the form of log AB. We also know that this one will be coming down, this part will be coming down as 0.059, and these two are unity because these are in solid form. So if it is in solid form, obviously the concentration won't be changed. So what we can do is we can rewrite the equation as this much is E0 cell, so it is E0 cell, right? We already know. Just let me adjust the camera once again. This much. So it is E0 cell, okay, because this much is E0 cell minus 0.059 by 2 log of Zn2 plus by copper 2 plus at 298 Kelvin. So this is the ultimate equation. It looked similar as Nernst equation, but how to deduce this equation, that is what is being written over here. Okay, so it is a proof, you can say, derivation of Nernst equation for a Daniell cell. Very, very important. This will give you the concept or the whole idea. How are we getting all these things? So write it down, copy it down, and this question can come directly also. So if we are supposed to write down in generalized form, it will look like if there is an equation, there is a coefficient of A, B, B after losing n number of electron. Okay, after losing n number of electron, if it is forming and d of t. So here we can take care of all the coefficients. So let us write down the Nernst equation. So it should be E is equal to E0. E cell should be is equal to E0 cell. We have seen how it is, minus 0.059 by n because the number of electron changes will be n only. Then we should be able to write ln in that case we should be writing log because we have taken 0.059 already. Now here you see these two divided by these two, right? But the coefficients will matter. The coefficient of C will be here and A and B will be here. Okay? And furthermore, we can rewrite the same equation as E cell is equal to E0 cell minus 0.059 by n log of Q, where obviously Q is QC also sometimes, but QC is the concentration part alongside their coefficients. This part is easy. So this is how the generalized form of the Nernst equation will look like. So here we can see in terms of concentration cells, in terms of concentration cell, say for an example, if it is given, say nickel, or say suppose copper sulfate, the concentration is C1, and then there is zinc sulfate, the concentration is C2, and then zinc, then we should be able to write as E cell will be is equal to E0 of cell minus 0.059 by 2 in this case log of, directly we should be able to write C2 by C1. So this is how the concentration cell will look like, and directly we can put the formulas to get the answer. So we are going to see some problems related to that now. Copy it down. Now we are going to discuss about the relationship between the equilibrium and the Nernst equation. Let us see how it can be done. So for that we will choose the simplest equation of the Daniell cell. We know zinc reacts with copper 2 plus gives rise to Zn2 plus copper. And here what happens with time, after a certain point of time they may attain equilibrium. If they attains the equilibrium, then see we will just plot a simple graph to let you know about the idea of it. So on this side we are plotting potential difference. Sorry, we are plotting progress of the reaction. So we are plotting progress of the reaction on this side and reduction potential on this axis. So initially when it is E cell, which is equal to ER minus EL, in that case we are expecting that the cathode will have higher reduction potential. That means we are expecting on this side, if I write E of Cu2 plus copper will have a greater reduction potential than Zn2 plus Zn. Now, so if that is the case, we are plotting copper in red and we are plotting zinc in blue. So in this diagram, the copper will have a very high value initially, check this value, and zinc obviously will have a very low value. Now, as the time progresses, what happens? We have to understand the situation of the cell, that Zn2 plus ion is going to increase because zinc is going to convert into Zn2 plus 2 electron, and as more cation is being prepared, so the tendency of getting reduced will be higher, so the reduction potential with time should increase. On the other side, copper 2 plus will convert into copper. Copper 2 plus accepts 2 electron, we know these things, and will convert into copper. So there will be lesser amount of copper 2 plus ions in the medium. So it will decrease. And at a certain point, you can see here, these two will intersect. And hence it will be having this kind of form. So as a result of it, this is called equilibrium point. So this is called equilibrium point. What is the mathematical output of this equilibrium point? So for that, we have to rewrite the Nernst equation once again. So Nernst equation for this will be E cell is equal to E0 cell minus 2.303 RT by NF log of, just I am writing the zinc 2 plus and copper 2 plus, okay. So it should be Zn2 plus divided by copper 2 plus. It can be rewritten as E cell is equal to E0 cell minus 0.059 by N should be, in this case it should be 2F, because here only 2 electrons will be transferred. So log of Zn2 plus divided by copper 2 plus. We have seen earlier, actually there are, if we just erase this part now, we know that actually there are copper also, and on this side it is zinc also. And this total part we can write down as log QC. At equilibrium, what is the condition? At equilibrium, it is E cell which will be 0, because at that point of time ER will be is equal to EL as we have seen, and QC can be written as Kc. Kc is known as the equilibrium constant. So we can rewrite this particular equation as 0 is equal to E0 cell minus 0.059 by 2f log of Kc. Again, further simplifying, we will be getting as E0 cell is equal to 0.059 by 2f log of Kc. Furthermore, it should be log Kc is equal to 2f E0 by 0.059 for this particular case only, and in general it should be log Kc is equal to 2, just a minute, f should not be there. If we are replacing it by 0.059, then it should be only 2, and here also, and here also. So f will not be there because if we are calculating, and then only we are getting this 2. So in general it should be log Kc equal to n into E cell divided by 0.059. Earlier I have written f, which here you see, if we are calculating, if you calculate f, then only it will come, and n in this case was n is equal to 2, but this is the generalized case. This is the generalized case. This is a particular case for this equation, and this is the generalized case for the equilibrium. So this formula we are going to utilize from here on. Once again, this f, if I had written earlier, erase it, f won't be there here also, and if the number of electron transfer is not known, simply we will this will be replaced by n. So in all these cases it will be replaced by n. That is what the general case suggests. This one.